Across the grasslands stretching through sub-Saharan Africa, creatures that spread death are being wiped out in large numbers. Rangers keep finding the bodies of black mambas and puff adders in the same condition, skulls smashed by a lethal impact and spinal columns carrying severe structural damage. These are some of the deadliest snakes on Earth, capable of shutting down the entire central nervous system in as little as 20 minutes. And yet the one turning them into daily hunting targets is neither a savage beast nor a machine built by humans. The hunter behind this relentless pursuit is a bird that gave up the sky and spent 15 million years evolving in reverse, transforming itself into a mechanical killing machine on land, the secretary bird. One aerial strike lasting exactly 15 milliseconds is enough to decide the line between life and death. Every day, one adult secretary bird can kill and swallow between 4 and 6 highly venomous snakes. It turns every hunt into an instant execution. Scientists at the Royal Veterinary College, or RVC, had to place a rubber snake fitted with force sensors in an experimental zone just to measure the destructive power of this bird. What they found stunned the entire field of biomechanics. One kick from a secretary bird can generate an impact force of up to 195 newtons, equal to concentrating 20 kilograms of force into an area no bigger than the tip of a finger. Even more astonishing, the entire motion of lifting the leg and striking the target happens in just 15 milliseconds. A human being needs around 150 milliseconds to blink. A black mamba needs between 50 and 70 milliseconds to launch a bite. That means the secretary bird attacks at a speed roughly 4 to 7 times faster than the strike of the fastest snake in the world. Before the snake's brain can even send the signal to release venom, its skull has already been completely neutralized. The body of the secretary bird is an exceptionally refined aerodynamic design. Unlike many flying birds that have hollow bones to reduce weight, its leg bones are dense, rigid, and strong like carbon steel. Its knee joints evolved into a complex shock absorption system that works on a principle similar to the suspension system of military vehicles. The moment its foot slams into a snake's skull, a muscular reaction called the snapback reflex is triggered immediately. Its leg rebounds in a tiny fraction of a second, canceling out all reverse impact force and protecting the bird's own bones from injury caused by its own power. The secretary bird's visual system works like an automatic targeting mechanism. With a field of view of 270 degrees, its large eyes can detect tiny muscle contractions in a snake hidden beneath grass 1 meter tall. It analyzes the defensive path of its prey and predicts the attack angle before the snake even moves. A huge region of this bird's brain is devoted solely to processing movement at extremely high frame rates, allowing it to experience the world as if everything were happening in slow motion. On an early morning in the Serengeti, high-speed cameras recorded a face-to-face encounter between a secretary bird and a black mamba measuring 3.5 meters in length. The snake lifted the front of its body, ready to deliver a fatal bite at a speed close to 5 meters per second. The black mamba lunged straight toward its opponent's leg. The secretary bird did not back away. It spread its wings, which measured 2 meters across, to disrupt the prey's visual perception and at the same time create a current of air that threw off the path of the strike. In 0.015 seconds, the bird tilted its leg and avoided the blow. The fangs of the black mamba only barely grazed the horny scales covering the bird's leg. Those scales are made of densely packed keratin, 3 times thicker than those of other predatory birds, preventing the venom from reaching soft tissue and blood vessels. The instant the mamba lost balance, the secretary bird delivered a vertical kick from above, crushing the snake's third cervical vertebra. Video data confirmed that the bird delivered 41 consecutive kicks in just 8 seconds. The black mamba became an immobile body before it could even launch a second attack. But its encounter with the puff adder shows this bird's brutality even more clearly. The puff adder does not strike first. It flattens itself against the ground and uses thermal camouflage to make itself nearly invisible. Many creatures have died simply by stepping in the wrong place. The secretary bird solves this problem with a tactic that could be described as cornering and forcing exposure. When it detects the slightest disturbance in the grass, the bird starts leaping around while repeatedly hammering the ground with force, creating small, seismic-like vibrations. The psychological pressure and the vibrations force the puff adder to abandon its camouflage, raise its head, and slide out into the open. The moment the snake loses the cover of the tall grass, the finishing strike arrives. The secretary bird throws 16 kicks in 20 seconds. When the snake arches its body to launch venom, a sideways kick from a 45-degree angle completely breaks its spine. The entire defensive system of this deadly snake is neutralized by a precise mechanical calculation. The tactical superiority of the secretary bird reaches its peak when it faces the Mozambique spitting cobra. This enemy attacks from a distance and can spit venom directly into an opponent's cornea from 3 meters away. So how can a close-range fighter defeat a sniper? In that moment, the bird's 2-meter wings no longer serve only as a balancing platform. They become a biological shield. When the cobra contracts its muscles to spit venom, the secretary bird immediately drops one wing to fully cover its head and eyes. The venom hits only dense feathers that contain no blood vessels. The sniper loses its shot and exposes its fatal weak point. The secretary bird charges straight through the cloud of venom still hanging in the air and knocks the cobra down on the spot. After every hunt, the way this bird consumes its prey also breaks every feeding rule followed by other predators. The neurotoxic venom and hemotoxic venom of snakes remain intact inside their venom glands, with enough potency to kill dozens of large animals. The secretary bird clamps onto the snake's body with its beak, lifts it into the air, and slams it violently against hard ground 5 to 7 times. This motion completely destroys any remaining muscle connections and removes every involuntary reflex from the corpse. After that, it swallows the prey whole, starting with the head. The snake's head goes in first and compresses the venom glands, preventing venom from leaking out or a fang from accidentally piercing the bird's esophagus. So what happens when some of the most dangerous venom sacs on the planet enter the stomach of a secretary bird? The idea that it has some kind of venom immunity is actually a misunderstanding. Animals like the mongoose or the honey badger carry genetic mutations in nerve receptors that neutralize venom if it enters the bloodstream. The secretary bird does not have that evolutionary privilege. If a secretary bird suffers a wound, a tear in the esophagus, or a stomach ulcer, it will die immediately after swallowing a venomous snake. It is engaging in an extremely dangerous digestive process with no way back. Snake venom is made of complex protein chains that become deadly only when injected directly into the bloodstream. Inside the secretary bird's stomach, gastric juices have a pH level of about 1.5, comparable to the stomach acid of crocodiles, strong enough to dissolve bones, horns, and scales. This superacid immediately breaks apart the protein structure of the venom, completely neutralizing its toxicity and turning it into an ordinary source of nutritious protein. The secretary bird swallows a biological weapon and turns it into energy for survival. This natural system for controlling venomous snakes worked perfectly until humans decided to apply land transformation methods to rearrange ecological balance across many parts of southern and eastern Africa. Large-scale commercial farming operations destroyed the secretary bird's habitat to make way for electric fencing and industrial agriculture. The disappearance of this top predator created a deadly ecological vacuum. Populations of highly venomous snakes exploded in number, directly threatening human lives and agricultural workers. Instead of restoring the habitat of this native bird, humans launched misguided ecological experiments called artificial predators. They began importing and releasing large numbers of feral cats and mongooses from India into the savanna, believing they could replace the secretary bird in eliminating venomous snakes. The result of that massive intervention was a brutal disaster beyond all prediction. Feral cats and mongooses, when confronted with the fearsome defense systems of the black mamba and the African puff adder, chose to avoid that battle completely. Instead, they began hunting much easier prey: quail, guinea fowl, native lizards, and small marsupial mammals. Endemic wildlife populations across the continent were devastated. Many ground-nesting bird species were pushed to the brink of extinction by these artificial predators introduced by humans. Even worse, industrial chemicals used to repel reptiles were poured into the soil, contaminating groundwater and destroying entire communities of decomposer microorganisms. The more human beings intervene, the more brutally the laws of nature reveal themselves. Venomous snakes continue multiplying out of control, while the only ecological killer truly capable of confronting them, the 15-millisecond predator, has been driven out of its own territory by human activity. Millions of years of evolution created a perfect machine for ecological control. By killing an average of 1,000 venomous snakes every year, a pair of secretary birds helps preserve biological balance across vast regions. By holding back the population explosion of reptiles, they unintentionally become the most effective safety shield for human settlements. And yet, an ecological tragedy is advancing with brutal speed. The population of secretary birds has declined by more than 70% in just 35 years. The International Union for Conservation of Nature, or IUCN, has officially raised its conservation status to endangered. The cause does not come from natural processes, but from human intervention across its living territory. Every day, a secretary bird walks between 20 and 30 kilometers to hunt, but it still needs to rise into tall trees to build its nest. The expansion of high-voltage power lines and telecommunications cables stretching across the grasslands has created deadly traps in the sky. Its 2-meter wingspan matches far too closely the distance between two high-voltage electrical cables. When the bird glides past with its wings spread wide, its body can accidentally complete the electric circuit. Currents of tens of thousands of volts electrocute it in midair. More than 10% of adult individuals die from broken wings and cranial trauma caused by collisions with electrical wires. At the same time, the natural fire cycles of the savanna have also been altered by human interference. Fire suppression has allowed shrubs to grow thick and dense. The secretary bird needs open ground in order to execute its attacks. In environments covered with dense brush, it loses momentum, cannot perform its snapback kicks, and ends up vulnerable to the very snakes it once hunted. Without open paths for hunting and movement, they stop reproducing. The collapse of this top predator immediately creates a visible consequence. In savanna regions such as Ikipia and Botswana, where secretary birds disappeared because of human interference, puff adder populations rose by 60%. Snakes began entering inhabited areas to hunt rodents. Medical reports recorded a 20% increase in snakebite cases among humans. The costs of importing antivenom serum and covering medical expenses rise into the millions of dollars every year. Humanity destroyed a free natural defense system with its own hands, and now it has to face the deadliest creatures directly. The ecological breakdown does not stop there. When the ground predator of the savanna disappears, snake density rises and human fear triggers indiscriminate extermination campaigns. The large-scale killing of snakes opens the door to a second catastrophe, a rodent epidemic. Rats and mice, with no natural predators left, multiply exponentially, consume thousands of tons of stored grain, destroy crops, and spread diseases like Lassa fever directly into human communities. In trying to control just one link, humans end up detonating the entire food chain. Attempts at relocation and artificial breeding to correct the mistake have failed in devastating ways. In the 1990s, projects that confined secretary birds in closed reserves in Namibia observed these animals either stop eating or begin tearing out their own feathers because of extreme stress. They cannot be domesticated, they cannot be moved easily, and they cannot be replaced by human technology. The global supply chain for antivenom serum is now facing a serious shortage. No factory can produce enough antidote if black mambas and cobras continue expanding out of control. A kick capable of bringing down a black mamba happens in only 15 milliseconds. But if this guardian of the grasslands disappears forever, humanity will have no way to reverse an ecological catastrophe that has already begun its countdown. The amount of venom building up beneath the tall grass will slip beyond control. The survival of the savanna will no longer depend on the power of venom-coated fangs, but on whether nature will still allow humans to keep destroying this ecosystem.